observe them and report back when they uttered their
And you
first
also
word.
give that instruction that nobody's supposed to talk any word in front of them.
Exactly.
To see what the first word.
What is the first word that they come up with? So the first word that they came up with was, after 2 years, was Bekos, which turned out to be a word from the Phrygian, which is a neighboring language of the Egyptians. Therefore,
and the word was for bread.
For bread. So therefore, he came to the conclusion that the first primitive word is
of
humans is bread, human. And the first language of humans are Phrygian. So now you know people laugh. Oh, these Egyptians, 2,000 years old. You know they were this.
No, but the thing, logic itself is a good logic.
That's fine. I'm not going to go into that. Otherwise, we will spend more time on it. This again was repeated in 1958 with birds by the British ethologists or ornithologists, or however you want to call them. Ethologists is basically people who study behavior, right? So now you would think that in more than 4,000 years, this theory has been discredited. Nobody should be repeating this all over again. But I leave it for you guys to judge for yourself.
Brother, the thing is, if you repeat this experiment, if you repeat this experiment,
yes,
and every time the word comes backwards, what you're going to do?
If it comes, it doesn't. It doesn't come backwards each time. That. As Einstein famously said, what is insanity? Repeating the same thing over and over again and expecting a different result. This is the definition of insanity Einstein came up with.
Repeating things.
Repeating the same thing over and over again and expecting the same result.
Yes. For example, switching on the button turns on the light, I can do again and again and expecting the same result. So if I do that, that's insanity, right?
No. If it is not coming,
no,
if you turn on
expecting different results, right?
Different results.
Yeah,
sorry.
Same thing. If I go to a machine, a gambling machine,
yes,
every time results are different, and expecting a different result, it comes.
So anyway, I don't remember the quote, so I will leave it there.
No, but with gambling, the thing is, when people go gamble,
they are expecting
the same. Technically, they're crazy because they're always expecting to win a lot of money.
Yes, they're expecting the same.
A certain amount of money, a lot of money. So long. So they're crazy too.
So anyway, let's do this one quickly again so that we can continue. So the guy did these 4 things. He's accused of doctrine, fabrication, selectivity. They heckle the guy with the embryo thing that we are talking about. And look at this. So, despite the fact that this guy has been accused of so many things, look at it. In 2002, Times Magazine, on the cover page, reported that a human embryo at 40 days looks no different from that of a pig, chick, or elephant. That's Times Magazine. Just imagine how many people worldwide now believe this theory. Biology repeats the same nonsense in 2010. Just think about it.
But you have to clarify how it is nonsense.
It's not clarify. I don't need to clarify it. The science itself says this is nonsense. So I don't have to say anything.
So you have to give us a quote at least.
Okay, that's fine. Remember, that was last week. I gave the quotes last week. Last week I gave all the quotes. Remember, where it's discredited.
That's why we are recording this time.
So, okay. So,
We are recording.
So,
I can remember everything.
So, now we were talking about. Do you want to ask? Let's just start the presentation. I will talk about this one later on. This is Einstein's life. Do you know how many mistresses he had? This is the list of some of his mistresses. People are not aware of that. Okay, so today's lecture presentation is, what is that? Is it 5? Functioning. Or okay. Is it coming? Okay. So before I begin, it's being recorded, right?
Yes.
Okay. So
No. You have to record the screen.
how do you do that?
Record the screen.
You have to record it.
The software probably has it recorded.
This is recording.
No, this is presentation time.
Yeah.
It doesn't say
You're
recording.
gonna put it on the conference call? That's what you're trying to do?
No. This always it's always there.
Skip it. Put a skip button. Now
Oh,
you have
okay.
to go
That's
to
what that's what-
view, slideshow, and then record slideshow. Record
From the beginning.
current slide, beginning, whatever you want. There you go. Now I do recording.
You going?
Yeah.
You good?
That's right.
Okay. So today's presentation is about, or the series of presentations will be about examining the scientific method. What is the scientific method? And is the objective of this scientific reasoning examination is we are trying to determine how objective is the scientific method. Can the scientific method lead us to evaluate things on an objective scale? That is the objective of this thing, of this presentation. So I prepared an outline. Obviously, we will not be able to go over all of these things at one go. So one of the things I would just like to go through the outline. The first slide I will present is about scientific evidence. What scientists have to say about scientific evidence. It's just one slide just to set the context of what we are going to talk about. We'll look into the scientific method, the history of the scientific method, models of scientific inquiry. There will be a small digression about reasoning. We will look at the scientific methods and its other components. Then we will start looking at each component at a time and examining the scientific method. So the first component of the scientific method, everybody, I believe, knows is the hypothesis. So what is hypothesis and what its role in the scientific method? Then the three other points that you see on the screen there is theory, relatedness, then Durham-Quinn thesis, and confirmation holism. These are basically fancy words for saying how do you verify a theory. These are all just fancy words. We will find out later on how hypotheses are built up and how they are evaluated empirically. There's a problem now. Another problem of the scientific method is something what is referred to as undetermination. Undetermination means basically how do you determine in light of the evidence how accurate something is. We'll go through some examples and present that. We'll talk about if there are more than one theory empirically, how do you accept one theory is better than the other theory? How does one theory replace another theory? How does the scientific method does that? It continues with commensurability, the concept of that is exactly what it means. How does one theory replaces another theory? We will look at some with the Big Bang model, the standard model of physics, the standard model of physics, whether it's really objective. There are two techniques that formal physicists use to modulate. Can I use the word modulate? Modulate, people understand what modulate means? Fine tune their theories. It's called renormalization and re-regularization. If the first time I came across this thing, I said I could do it myself. If you want to fine tune a theory, I can do it. It's not really very objective standard. A big component of the scientific method is bias, and we'll spend some time on bias. What is confirmation bias and what's its role in science? We'll take an example of the confirmation bias and general relativity, that is the theory of Einstein, and what role confirmation bias played in general relativity. People
I don't think we'll be able to cover all these things today.
no,
Just a start.
this is just an outline.
Outline, and then we'll see how much we can cover.
This is not going to be covered even in 2 days, two Saturdays. I'll just give you an outline so that people are aware what's going on, right? Experimenter bias, how the bias of the experimenter, which Dr. Fawad we were just talking about that, right? About the double slit experiment. 6 types of experimenter bias. There are examples we will look at. What are cognitive biases and what their roles are in the scientific method. What scientists have to say about bias in the scientific method. Another big component of bias is bigotry, prejudice, and cultural bias in science. This is something that most people do not relate with science. Scientific racism is a reality, and how not racism in science. I didn't say racism in science. Please note, I said scientific racism. So there's a big difference between racism in science and scientific racism. In the name of science, what scientific theory have done to the human population worldwide, I don't think anybody in this room really knows what it has been done. I can safely say that, because when I was growing up and I was reading, I came across this. Even when I came across an article about 6-7 months ago, I was blown away. So we will examine that. We'll look at justification of science, and this is a very I call it the repackaging of science. And one article that just came up last night, when I was writing this up, I came up across it. I said I will include it. Is what does science have to say about making a good apology? According to science, what would constitute a good apology? I think it's a very good, interesting thing that we can explore. Then this is not the all about the scientific method. We have the observer effect in physics. We have the look elsewhere effect in physics. After all this examination, we will look at what do people have to say about, after knowing all these problems in the scientific method, what do scientists have to say about this? So there are 3 areas what we can talk about: pessimistic induction, half-life of knowledge, and there's a book that was written back in November, but what if we are wrong? Thinking about the present as if it were the past. It's a very interesting book. Basically, the thesis of the book is saying this: what history has taught us is that everything in the last 4,000 years ago that we knew has turned out to be false. So what is the guarantee that 2,000 years from today, what we know today will be right? You got the thesis? It's a good exploration by the author. There are good examples there. We have the reproducibility crisis that we talked about in our first lecture, whether that is one of the criteria of the scientific method, is to be able to reproduce your experiments, right? Unbiased. Is it really true? It is not. I can give you the statistics. It was there. Then up till now we have been talking about the unintentional effect of the observer or the human being on the scientific method. Now we come to the intentional misconduct by scientists in using the scientific method. Intentional. You understand? This is up to now what have we done? Is unintentional, intrinsic. Now somebody goes out of the way to actually, abuse the scientific method. I don't think many people have even gone across that. Many people, many major scientific studies have been blown out of the water just because they were later turned out to be fraud. And these were being reported by reputable journals like Nature, Physical Sciences, and all that. And we look at the criticism of the scientific method, and finally we talk about discoveries in science, how they come about. Any questions?
The question will come when you come. When you start.
So let's start with the first one. I don't know why this is coming like that. Is the scientific evidence. Uh, is it this? Yeah. Okay.
Go back.
This is fine.
That's your slides from.
This is my slide problem, right?
Yeah.
And somewhere from the slide. This is really bad. Like, take it out.
Take what out?
No, I'll just go out of the presentation. Out of the presentation.
So you know what you do? Go on the right click on the presentation, on any slide, right click, go to format, background. Here, click here in the corner.
No,
Outside,
outside.
further up.
Yeah, outside. On your right.
On the gray. On the gray maybe.
No,
Okay.
not gray. You have to
Format background.
Just make it
Solid fill.
Solid fill and one color.
And print black color.
That's it.
This one?
Yeah,
Yeah. Apply all.
Okay. You can clear.
Back here. We got from the
From
Okay.
outside. Yeah. Okay. You can start.
Okay. So the scientific evidence, the first thing I would like to just point out here, the godfather of scientific philosophy of science, Karl Popper, this is what he has to say about proofs in science. In the empirical sciences, which alone can furnish us with information about the world we live in, proofs do not occur. If we mean by proof an argument which establishes once and for all, forever, the truth of a theory. So are we clear on that? So that means science cannot furnish a proof that's here. This is a proof and this is true for all times, forever. He says it can never be done.
what are you talking?
This is what this is. Correct me if I'm wrong. If somebody, if
In
that's
empirical sciences. For example, mathematics.
yes. What is mathematics? So this applies to mathematics too.
So the law of equation, they're proven.
Yeah. So
We prove the equation, they're proven.
when we come to proofs, we will talk about what that proof means. Okay. But this is why this is the reason why I brought this as a first slide. The reason why I want to set up the context. If a religious person comes up and says, I cannot furnish a proof, absolute proof for you that the hereafter exists, you laugh at that person. Am I correct? Am I wrong? I cannot furnish an absolute proof.
Judgment day will come.
I can't prove that. And I believe that. I can give you rational arguments for that.
Yes.
If you want an absolute proof, I cannot. Right?
You can take home a test kit, and you can perform the test there.
No, I
To
cannot.
prove it. You can't.
But that statement is laughable. People laugh at that and call it irrational. They call it judgmental. They call it belief. Various words. This is the godfather of philosophy of science. He's just saying this. Why aren't we laughing at that? I just leave it as a thought for you guys. So this is the scientific method. So this is actually I wanted to start with something else, but I forgot about it. If any myth can ever come out of colonialism and colonial education, I think is the scientific method. I don't know how many people have heard about Macaulay Memorandum in the Indian subcontinent in British India.
Lord Macaulay.
Not Macaulay. So he was the secretary of the British section of, or I don't remember what he was. He was tasked with setting up an education system in British India. So I can't remember the full code. We can look it up. So the full code goes like this: the aim of, I'm paraphrasing here, the aim of the British education system in India would be to set up a class of people, brown in color, right, but white or British in their intellectual understanding. That's the paraphrase of it. And I think the scientific method played a big role about it. When the critique of the scientific method was taking place, it didn't happen in the 1940s and 50s and 70s. Actually, people had started criticizing the scientific method back in 18 something. And they knew very well that the scientific method could not lead to the truth. However, this diagram that you see, that we make observation, we do hypothesis, formulate hypothesis, we test, and we develop general, refine. This has been embedded into the psyche of almost all people that have been governed by colonialism. They think that this is the method, and that is one of the reasons why I picked this topic to talk. That this diagram that you see here, what does Lee Sommerlin is a physicist, one of the eminent physicists, current physicists at Harvard and Princeton and whatever you have, and Paul Feyerabend, who is the third godfather of philosophy of science. Look at what they have to say. They have argued there's no thing as such as a scientific method. Just think about it. This model is repeated to every one of us as an absolute fact. And look at what it.
Now even in the social sciences they are using it.
Yes, everywhere they use it. At our jobs, we are told to do this way. Am I correct? This is there's no other way to think of solving problems except this way.
Nobody says that. That part nobody says.
Not says what?
That there is no other way.
They may not say it explicitly, but implicitly is always there.
It's implied.
It's always implied.
Actually, scientific in that sense, they use different terms like rational and logical methods.
Yeah, but this is this is the component of the scientific make observation.
So what's wrong with that?
We will continue. We'll see it.
Okay, let's continue.
So I just wanted to share with you that is the component. So the history of the scientific method basically means that this is not something new that just came up. You can see that Egyptian, every person, and I can tell you from my own example, I grew up in rural Africa, but if you go and ask somebody how far that place is, they will be able to tell you. They use reason, and they have some kind of method by which they will tell you how far that place is, even though you may not understand kilometers and GPS and all that, but he does. So they are using some method, some rational method, to arrive at that the answer that they're providing us, right? Ibn Hatham is considered to be the one who laid the modern scientific methodology of observations and testing and reproducibility and all that. There's a very interesting reason thing. Reproducibility came after the 600s, that after the arrival of Islam. So it's very interesting to see the correlation between that. I will explore that in some other time. This is the timeline of the history of the scientific method. So here are a few examples of how people have been using scientific method at different times in the history of the world. Here, Avicenna is Ibn Sina. Sorry?
Somebody else.
Okay. Ibn Sina is here. Avicenna is the Latinized version of Ibn Sina. Biruni, Al-Hazan is Al-Haytham. So, next, we should also distinguish between what is the scientific method versus what is the goal of scientific inquiry. So these are two different things. People always sometimes conflate the two together. The classical model of scientific inquiry is, reasoning is threefold: abductive, deductive, and inductive inference, also using analogy. Here I'm just trying to recap here what is deductive reasoning and inductive reasoning is. Do we want to go over that, or I should just skip this? And
What is abductive?
I knew that question will come up. So
From a medical doctor, for sure.
So deductive is basically, I'll just recap.
Yeah.
Deductive is basically you have a premise, and then based on the premise, you make a statement, and based on those two things, you draw a conclusion. For instance, example, I would say all men are mortal, right? Socrates is a man, right? Therefore, all men are mortal. Or, the other way around, you can put it.
Deductive means you start taking things out of it, and whatever remains behind is your final theory.
No. Deductive means you start with a premise, and you make a you make a statement, and then you draw a conclusion from based on the premise and your statement. This is what it is.
So where the statement comes from?
The statement is your hypothesis or your
Idea.
idea.
Okay.
Inductive is where you try to, from a specific example, you go to a generalization, right? Like you see a bird, it's white. You say, oh, okay, it means all birds are white, for example. That is what, that's what
So
it,
today you see a bearded guy, you see he's a terrorist, and then you all.
that is
say
inductive
he's a
reasoning.
terrorist.
That is inductive reasoning, yes. That is inductive reasoning.
It really works with media.
That is inductive reasoning. That's true. And that's where stereotyping comes about. Yes.
And what is abductive?
Abductive is initially abductive. So just give you a background. Model of reasoning so favored in the last 200 years by modern knowledge is being either inductive or deductive. Sorry, rephrase. Deductive or inductive. Deductive was preferred because it was so-called foolproof, and it was always used in mathematics, mathematical formal sciences, mathematics and logic. And inductive was used in more empirical sciences like physics and chemistry and other generalizations. However, critical examinations of both methods produced their limitations, and they were no longer foolproof. In fact, induction's death knell was what was his name? David Hume, the philosopher. He totally demolished the method of induction. So from that point onwards, people, philosophers and scientists are trying to go away from this method. So abduction was least used method. It was always there, but it was the least used method. In basically, abduction, I will explain by an example here rather than try to explain the definition.
So abduction basically is like you observe something and look for the simplest answer.
Exactly. So the example is this. If it looks like a duck, swims like a duck, and quacks like a duck, then it's probably a duck. And I think doctors use it most because these are the symptoms, these are the things, It is always used in politics also. This is used by, I give you two contrasting examples here deliberately. One is used by the United States ambassador to Guatemala during the Cold War, and recently used by Russian foreign minister in Syria. If it looks like a terrorist, acts like a terrorist, walks like a terrorist, fights like a terrorist, it's a terrorist, right? There's no inference here, there's no deduction. There's no...
Brother, can you mute your phone, please? Thank you.
So, that's abduction in a nutshell. I don't want to go into details of this thing, but I hope you guys got the idea what abduction is. This was not used previously because now it's being used. Why? Because it's being used in computer science and is aided by computer power. So the computer processing power can go through all possibilities and then come up with the result, right? So that's why it's getting a resurgence in, like for example, that
AI is going to be a good application. In AI.
yes. Why? Because what's the institute, medical institute in Minnesota? It escapes my mind. There's a medical institute, big institute, health institute in Minnesota, Minneapolis. They have started using AI for clinical diagnosis, and they're using this method. I don't remember the name. IBM has done. I will give you the names. Abduction is used is sometimes known as the elephant test too, and this is famously quoted by the Supreme Court of the United States.
Al-Hakim.
Al-Hakim.
वो आपकी जो बात की थी शुरू में उसका जवाब आ गया.
Okay, so he stated that we were talking about legalizing hardcore pornography during the 50s, between when Playboy fought for their First Amendment rights. So this is what they came up with. He said, I know it when I see it. This is the basis of the legal judgment. So there's no formal induction, no, there's no deductive or inductive modeling here. I know I see it. What does it mean? I know I see a drunk person. It's interesting. There's other forms of reasoning that is being used. I'm not going to go into all this reasoning, but I just put it there for us to see that these are the components of the scientific method. So, why am I putting it there? This is the question I have. I hope it's now clear that there's no foolproof way to just reason and come to a conclusion. Would I be correct in saying that? I leave it to your judgment. There's no way you can say this line of reasoning or this form of reasoning will give me guarantee a result. It cannot. We can see from the examples here. They're
an application of different kind of reasoning.
Yes. So, recap. I will just go. Deductive reasoning is from postulates, premises. Probabilistic is from probability. And statistical is from data and presumption. Inductive we discussed. Deductive we discussed. The other models of reasoning, but that's okay. The other component of the scientific methods are replication, external review, data recording and sharing. Remember, we went on a digression. We are talking the scientific method. So, apart from the hypothesis and other things that we just talked about, testing, observation, and all that, another component of the scientific method is that it should be replicatable, right? Other people should be able to replicate it. It should be available for external review. Is not I hide my findings. I won't share it with you. And that is what distinguishes pseudoscience from science. Pseudoscientists will never share their findings. Data recording and sharing. That means the data is available and it can be shared. Right? These are the vital components of the scientific method. So the first thing that we can look at is the ad hoc hypothesis. What is an ad hoc hypothesis? Basically, an ad hoc hypothesis is a hypothesis that is added to a theory in order to save it from being falsified. Did everybody get that? That means, let's say I form a theory. I'll give you an example. I will give you an example.
Like in the classroom, when the student is lying, his friend comes in and gives him a fee to the teacher to save him from being caught, obviously.
Yeah, that's well. So give you an example. Brother Mirdad comes to my house, and I tell him, Brother Mirdad, in my my little room over there, I have a dragon. A dragon lives in this room. He says, what? I like to see it. Everybody wants to see a dragon, right? So he goes there, opens the door. He says, brother, there is no dragon here. Oh,
I forgot to tell you.
So what is that? He's invisible. Oh, Brother Mirdad is thinking now, how do I see this? So he says, you know what? Brother Mirdad takes powder out of, talcum powder, flour or something out of his pocket. He says, I'll throw it on the floor, and when the dragon walks, I can see the footprint. I said, Brother Mirdad, I again forgot to tell you. He only lives in the air. He doesn't touch the ground. So what am I doing? I am producing ad hoc hypothesis on demand. Ad hoc means on demand, in order to save myself from being falsified. You got that?
You're BSing to make a hypothesis seem valid.
Exactly.
A lot of religions did the same thing.
Instead
of going back to the scripture, they have now the explanations developed from nowhere.
Exactly. So basically, what this is saying is, if you want to stick to your view, you can always add an explanation, a rational explanation, and stick to that.
Or whatever objection comes, you make an answer for that.
Correct. Same thing. Yes. For example, I think, are we clear on what ad hoc hypothesis is today? People are very much surprised. They think ad hoc hypothesis, what Brother Fawad is saying, is it is only exclusively for religion? They are very much surprised that science and the scientific method does this on a daily basis. For example, theory of relativity produced initially a static universe, and he said the theory of relativity produced an expanding universe initially when Einstein produced it, right? Then he saw, oh, it doesn't agree with my viewpoint. So he introduced what he called the cosmological constant to make it static. That cosmological constant was totally ad hoc in order to satisfy his subjective viewpoint. You got that? You got that?
Yeah, I've got the.
And we will come to this when we talk about the standard model and the free parameters of the standard model. Inshallah, we'll talk about it at that time. More on this thing. So, have we got about ad hoc hypothesis?
Yeah. Yes.
Okay. The famous ad hoc hypothesis that I really want to touch upon and is the inflation in cosmology. So, the problem with the Big Bang models are four. Those are the four problems that the Big Bang model, in the scientific terms, cannot explain. What is that? Why the universe appears to be the same in all directions, isotropic and homogeneous, right?
Isotropic, that means same in all directions?
Yes.
Okay, interesting.
And homogeneous means, equally distributed.
Dispersion is equal.
And why the cosmic background radiation is distributed evenly? You must have heard about this before. Why the universe is flat? Flat means there's no curvature on the universe.
Is that confirmed though? Or is that
No.
theory?
That's what is observed. Is it really? We don't know. Okay? And why there are no magnetic monopoles? Let me just explain about magnetic monopoles. You can have an electric in this. This is one of the mysteries of
What is monopole?
Okay.
Magnet always has bipolar.
So everything has dipoles, right? You have a positive and a negative.
Yes.
You have a north pole and a south pole. You can separate the positive electric charge and the negative electric charge. You can separate them, right? They can exist independently. But if you take a magnet and break it, immediately it becomes a north pole and a south pole. Continue breaking it, it always
Each piece will have a north and south.
north and
Negative
south.
and positive.
North and south pole.
Every sorry, yes.
Every piece. According to the science, there should be no reason why there shouldn't be an independent north pole and there shouldn't be an independent south pole, a monopole. If it doesn't exist, then there's a big question why. According to the scientific theory, everything has a positive and a negative, and you can electromagnetically, in electricity you can do that. But when you come to magnet,
The question: what happens when you break down it to an atom level?
same thing.
So where's the charge? Magnetic charges. Where's the magnetic forces then? In the proton?
Yeah, wherever they are.
Protons and
The electromagnetic fields.
Proton contains the electromagnetic.
It has a magnetic charge which has a north and a south pole. Yes. All particles have, unless the particle is neutral, magnetically neutral. That's a
Is
difference.
that what the difference is between, I forget now,
So how
proton and neutron? Is that one is negative, one is positive?
No, that's the electron and proton. Neutron is electrically neutral. So there are three things in electricity: positive, negative, and neutral. But in magnetics, it's only two: north pole and south pole.
Okay.
There's no neutral. There can be neutral elements that are not magnetically affected. That's a different thing altogether. So, to explain these four things, if these four things cannot be explained, then Big Bang fails. Right? So you don't want the Big Bang to fail. You don't want my theory of the dragon. I don't want Brother Mirdad to go away thinking I lied. Right?
So you want to keep him under the impression that you actually have
Exactly.
a dragon.
So just think of it in a one-to-one correspondence. So you want to keep the Big Bang theory, But you have a problem. You raised 3 objections. I supplied all the things. So here, scientists came up with an inflation model. What basically it said, when the Big Bang started, instead of the expansion that we see right now, the slow expansion that we see right now, there was a burst of inflated expansion. Right?
Okay. And then slow down.
And then it slowed down. To explain all these things.
What are you talking about? How can this be?
That's, we can
What
go into.
slows down in a vacuum?
Then there are exotic mechanisms of dark energy and other things to resolve that problem. We're not going to do that.
Okay.
The issue is with the point that we want to make here is inflation is an ad hoc hypothesis added to the Big Bang model.
Okay. Move on.
We all agree?
Yes.
Go on. So what do people have to say about the inflation ad hoc hypothesis? Roger Penrose, who is one of the eminent scientists of this.
Reality.
This is the reality of. Oops, where did I go? This is the reality of the inflation by a factor of 10 raised to power Google. That is the probability that it has happened.
What happened?
Inflation happened. He dislikes it so much.
In his opinion.
Yes. What is his? John Ehrman published a thorough critical review of inflationary cosmology, concluding we do not think there are as yet good grounds for admitting any of the models of inflation into the standard core of cosmology. Have anybody heard about these things? No. You only hear about my dragon. It exists in my house. But Brother Mirdad's visit to my house and his questions, they are never publicized. Why? Because I still want revenue coming in, people visiting, and I'm taking the money. Right? So, one of the founding fathers of inflationary cosmology has become the sharpest critic of inflation. Can you believe that? I form the hypothesis, I work on it, I give all the explanation, and then I turn on it. It happens. See that? So ad hoc hypothesis is that. These are the current examples of ad hoc hypothesis being added to general relativity in the news. That if you want, we can go over this. There are points where the general relativity fails, but then you put some explanation on there.
Can you just read the names at least so the recording they're there?
Okay, so we have the giant ring of galaxies scattered during Andromeda flyby challenges, Einstein's theory of gravity, gravitational waves may defeat new theories of gravity, new star system, challenges Einstein's theory of relativity. So all these examples are questioning the theory of relativity, right? But then what the explanations are all ad hoc added to relativity so that relativity does not fail, right? We are at 12:24 p.m. Do we want to continue or want to?
Your time is, you have little more time because Maulana Qasim didn't show up today.
Okay.
He excused because of some urgent matter came up.
Okay.
So you excuse so you have more time. If
Okay.
you want, you can continue.
Okay. So just let me summarize up to now what we have done. In the scientific method, the formation of hypothesis and then the adding ad hoc hypothesis is relatively unknown to us. This is what we have just learned, that in the scientific method, ad hoc hypotheses are added to make the theory being falsified. Something which is strange to our common understanding of the scientific method. Right? Just one observation here. If this is true for such strong empirical sciences, how would it be for the social sciences? Can we extrapolate on that? You know how ad hoc hypothesis will be entered into psychology, anthropology, physio, those kind of sciences. You know what I'm saying?
Yeah.
So theory ladeness is another problem in the scientific method, which basically means they are affected by the theoretical presuppositions held by the investigator. So the very fact that I'm forming a hypothesis is affected by my world viewpoint, something presuppositions that I have. For instance, I'll give you from cosmology. There are basically two theories in cosmology. One is the cyclical model, and one is the linear model of the universe, origin of the universe. Right? Guess who favors the cyclical model most? Can anybody guess here? Who favors the cyclical model of the origin of the universe? Who are the people who favor that most? Most of them.
Nowadays, a lot of scientists are.
No, the scientists. What is their world viewpoint? What is behind that? You will notice that those scientists who hold the world viewpoint of either Hinduism, Buddhism, New Age thinking, they are the ones. They are the ones. That doesn't mean there is no crossover. Don't get me wrong. But they are the most people who believe in the cyclical theory. It ties with their world viewpoint, right? And who believes in the linear model? Like the Big Bang model and other things. You will see that most of these scientists are coming from a monotheistic background.
Can you explain cyclical model to me? I don't really.
So cyclical model is basically, from a logical point of view, the universe can either have a beginning, right, and then goes to an end.
Yes.
Big Bang, for instance,
There's a beginning.
and then a big crunch,
Okay.
or big freeze, or whatever model you want to come to. So time is linear. It starts and then ends.
Right.
A cyclical model, on the other hand, is you have a beginning.
Sorry, can you repeat the other one, please?
Sorry,
Quickly repeat this one.
the
Linear one.
linear one is you have a beginning. Time equals t0, for instance, and then it goes to time t whatever, and then ends.
So that's about the time only, right? What about the matter?
It's same thing. It begins from
Everything
from time zero,
Before that,
and
nothing.
then before that there was nothing, and after that there's nothing, or whatever viewpoint you want to have, pre and after.
When the
on the-
cyclical ways goes on and on.
So the cyclical starts at t0, it goes through a cycle, and then it comes back. Like for instance, this is what is called the big bounce. So what they
Big
say,
bounce theory, yeah.
the big bounce is this: it starts with the big bang, it expands to a maximum size, and then gravity pulls it back. It goes back into a singularity, and then there's another big bang or big bounce, and then repeatedly it goes in that cycle.
So a lot of scientists are now believing in the cyclical one.
So these are the only two. Logically, these are the only two possibilities, right? You will see most people are coming from a Hinduist and Buddhist background, tend to prefer the cyclical
They
model.
live in reincarnation.
Yeah.
They believe in the cycle of life.
Then die again, become a rock.
Yeah. They believe in the cycle of life.
That is the place where they picked up this idea of cycle.
So,
Yeah.
whereas from a monotheistic point of view, either Judaic, Christianity, or Islam, you have a beginning and you have an end.
Yes. Yeah.
So, this is what theory, when they are affected by the theoretical presumptions held by the investigator. Right? So you think that that person is looking at it objectively, but is not. Yeah, does not mean that he's doing it intentionally. Don't get me wrong on this thing. It doesn't mean he's doing it intentionally. He may, but at this point, the only thing we can say is unintentional effect. He's affecting his objectivity unintentionally. Right? There are two forms of it. There are two forms of them. The theory layer, one is semantic form, and then there is perceptual form. Actually, this philosopher of science actually discussed three forms of it, and we will not go into details on this. But I hope you guys got the idea of what this means. So from here, the two philosophers called Duham and Quinin, they formulated this thesis, which says that it is impossible to test a scientific hypothesis in isolation. Okay? So basically what Duham and Quinin analyzed the scientific method, and they came up saying that when someone presents a hypothesis, it's actually not a single hypothesis. Actually, I'll give you an example. The example actually illustrates this much better. It's not a single hypothesis. It's a bundle of hypotheses that's going on. Okay? And it is impossible to test each one of them. In fact, Quinin even went further to say that this is not only true for science, it is true for all knowledge. So, but we will not go into that. Confirmation holism is what is the previous Durham Quinin theory is about, which says. So this is we says basically here is called. In isolation, you can't test anything. You have to test something in a whole world framework, right? This is what holism is about. So you can keep it from being falsified if you make enough drastic adjustment elsewhere in the system. And this is where Brother Fawad's statement is so true. That's what religious authorities used to do. Is if somebody comes and challenges something, they'll make enough adjustment here and there to keep it intact. Where's the next one? There are two kinds of confirmation holism. We'll not go into details on that. This is where it is. This is what we are talking about. Bundle of your hypothesis. So we'll take an example here, and I think the example will quickly explain to you what this is about. So imagine using a radiometric dating technique using uranium and lead. People are most familiar with carbon dating, but actually there are other forms of dating also through different element ratios. One of them is uranium and lead to estimate the age of a rock. The test suggests, suppose the hypothesis that the rock is 3.8 billion years old. This might seem to be cut and dried, but in fact there are many other hypotheses hidden within this test, including these are 5 other sub-hypotheses hidden in this test. What are these? The half-life of uranium is 4.5. The half-life has been constant. The sample rock has not been contaminated. Neither uranium nor lead has leaked out. The equipment that we have accurately detects the amount of uranium and lead in the rock. The last point, please remember it in mind, when we discuss the relationship between science and religion, and we discuss the Galileo affair, the conflict between the Catholic Church and science, this last point will play a very important role in our discussion. So, what is it saying? It's saying that this rock being 3.8 billion old is based on these 5 other hypotheses. If any one of this is wrong, our result will be wrong. But what he's saying is that it's impossible for us to verify all of this. If we can verify, let's say, 1, 2, 3, 4 out of this accurately, we will assume that the 5th one is okay. You get that's bundle of hypotheses. So this is another way of saying bundle of your hypothesis. These things these are called auxiliary hypotheses. Auxiliary to the main hypothesis. So what it's saying is these are the working assumptions that we work with, and all tests involve auxiliary hypothesis. There is no scientific method that I know of that does not involve the auxiliary hypothesis. There has to be one. If you don't have one, that means that you're doing something wrong. So, but what's the point that I'm trying to make? But not all auxiliary hypotheses can be tested.
What is auxiliary hypothesis?
These ones.
Bundling up is called auxiliary.
These are the auxiliary hypotheses, the individual ones that are coming.
Extra hypothesis.
Extra,
What extra?
not extra. I would say sub, hidden inside your main hypothesis.
Oh, okay.
These are
So
hidden
what is the
inside.
main hypothesis of which these are?
What we will say what is explicit and implicit,
Right.
right?
Okay.
Like example, brother Fawad was asking at the beginning of the lecture is mathematical proofs. They are forever, right? So, and you did. Have you done some mathematics, like sum of angle of a triangle?
Yeah, back in high school.
We are taught that the sum of the angle of a triangle is 180 degrees, right?
Yes.
Yeah.
That was a theorem.
Always.
That is a theorem that everybody knows about. It took 2,500 years for mathematicians to come to know that that statement is based on an assumption which can be falsified.
Interesting.
With a flat surface assumption.
So that what is the assumption? I can just demonstrate it for you. You
Flat.
imagine the globe, the Earth. You take a triangle on the Earth
on a
from the
round
North
circle.
Pole as one vertex and the equator
On a
two.
spherical surface.
On a spherical surface.
Make a triangle.
The triangle will add up to more than 180 degrees. Yes or no?
Yes.
Yes. So that means that assumption is
Theorem has been proven false.
why? Because the assumption is it was on a flat surface. Nobody bothered to identify that.
And no place it was mentioned in the theorem that it is for flat surface only.
Correct.
It was implied.
And
It was.
it was
In fact, nobody knew about that.
Yeah,
It took
that's
2,500 years to understand that problem.
we've been reading thinking that that's the ultimate
I
truth.
always whenever I use this example from mathematics to demonstrate the intrinsic problem or the changing nature of mathematics, people have a hard time accepting it, not because they don't believe me or they don't understand that, but because it's so ingrained in the mind that mathematics is rigid, formal, nothing can be wrong in mathematics.
I think that's why a lot of people, especially like my generation, don't find math as interesting, especially growing up in this country.
Yeah, because
They feel it's too rigid and so it's boring.
no, because math, that's another one
You
thing.
can't challenge it.
You can no, they don't teach you mathematics. That's the problem.
Yeah.
So you can never enjoy mathematics.
You can. Most people don't.
You
Or
can-
science too.
You know that example from the abductive reasoning? Actually, that is the one that actually took me to mathematics. But that's another story. But the reason why mathematics is not liked by anyone is because mathematics.
Not don't anyone.
No,
Many-
most people.
Many people of my generation, they grew up here.
Most people is because you do not see the connection between mathematics and the real life.
Yeah. To be honest, I remember when I was in grade 12, and one guy, he was a class clown, you can say. I was never taking anything seriously. But he was always saying to the teacher, when am I going to use, it was calculus, when am I going to use this in my life? When? What is the point? And she never had a real answer for it.
So I will give you a real life example. I took a course in abstract algebra.
Okay.
It's totally abstract. This is not algebra of the ordinary algebra. This is group theory. This is the fundamental problem that I kept having was how the heck do I use it? So luckily I found a book in the library, the application of group theory to the to pharmacology, how you manufacture drugs. So I'll give you in simple terms, protein folding. You know, proteins are made up in our human body. They fold in a particular way. We know that. And you know, the drugs, the way to design drugs, the best efficient way so that they can bind is to understand how that folding is done, so that you can mimic that action. You can have that the chemical go and mimic that action, so that they can bind correctly with whatever you are trying to achieve. And all this can be really modeled using group theory. And after that, I became so much interested in group theory that people started asking me to give me lectures on group theory, because I really started doing that. So
I don't understand. What is group theory?
Group theory, in very simple terms, is you take a group, like rotation. You understand rotation, right? It can be modeled as a group, and then that abstraction, when it's done, you understand matrices, right? Matrices, how matrices are written. Matrices you think of matrices as a group, which you can rotate and do other activity with it, and then try to simulate different real life models. I'll tell you later. So basically, this is your bundle. Your hypothesis is all that. So I'll give you a real life example of how an auxiliary hypothesis helped invalidate a correct scientific theory. So today we believe that the sun goes around the earth. Sorry, the earth goes around the sun.
Yeah.
Right? The heliocentric view.
Yeah. Heliocentric.
And before it was formally a geocentric view, that the sun goes around the earth. So Copernicus proposed that it's going to be heliocentric, right? So what was the first test of a heliocentric theory? It should be that the distant stars, they should be, if I'm observing a star, let's say star A in June, it should shift, that position should shift relative to that, say in December. In 6 months, we should be able to observe the parallax. You understand parallax, right? Parallax is basically you are trying, the example is right over there, is if you cover one eye with your eye and then look at a distant object, and then you cover the different with a different eye, the object jumps, a small jump in the position. That jump in the position, you can actually create a small triangle and then determine how far it is away.
Mm-hmm.
Right? That's the method of triangulation. Right?
That's how we see how far stars are.
So that,
Assuming that
So-
space is flat.
we'll come to that. So that was the first test of the heliocentric theory. We should be able to see the parallax of the stars, the movement, the slight movement of the stars between January and June and December. The different positions, different times, the stars should be in a different position, the same star. So what happened?
Also, by putting two telescopes, you can see that.
If they are the other both ends of the universe, at the end of the Earth. But that's okay, very good. But that small angle, look at what's happening. So this is what was happening. You see the background stars. The Earth is in July, and the Earth is in January. You are trying to measure this star. You can see that this triangle is formed, right? You know this distance, and you can form this triangle and try to determine the position, right?
Yeah.
Okay. Now let's go to the next one. So what happened? They couldn't detect any movement. Each time they came back, the position of the stars related to one another seemed to be the same no matter the time of the year. Copernicus' idea was rejected by astronomers of the day for this and many other reasons. So what went wrong? We know that there is
a triangle.
We know that, but why was it wrong at that time? Why weren't astronomers?
They're talking about relationship of the star with other stars.
No. So I'll tell you what will happen. The astronomers had assumed there was two auxiliary hypotheses embedded in this main hypothesis. The stars are not that far away. This is what they were assuming.
Because they can see it in the sky, I thought, oh, it's nearby.
Okay, yeah, very good. The next one was the observational tools were not sensitive enough to detect, I should have said not sensitive enough to detect parallax. So what happened was, actually, instead of this big triangle that you see, you are going to get something like this.
It's like trying to determine the distance of something with only one eye.
That is correct.
You don't have the proper depth perception.
Exactly. So now, if this is so far, this is for the nearest star, right? Imagine how far the stars are. And when did we start detecting the parallax? 16th century astronomers came to the wrong conclusion about the parallax test. Why? Because they saw the test results as this thing, because Only 21st century equipment were able to detect that.
Yeah.
So
What's the point?
the point is,
This goes back to the ad
also-
hoc hypothesis and auxiliary hypothesis.
correct. It's saying that even though you might have a right hypothesis, the auxiliary hypothesis you may not be able to test it. That's why you reject the main hypothesis. So this actually gives a false negative in this example. In other one times you might have a false positive, which I also have example for.
When
But
you
it's
say
not-
false negative, I mean,
This is false negative, meaning that even though it was true that the Earth goes the Earth goes around the sun,
Yeah.
at that time they said it was false. Right?
yeah, no, I get that.
You got it?
Yeah.
So think about it. There's an important digression that I want to make here. This particular difference of opinion between geocentric and heliocentric viewpoint is regarded as one of the three landmark theories which differentiate science and religion, right? Because it was said that the church was totally opposed to a heliocentric thing versus geocentric, and they persecuted Copernicus.
Yeah.
I think this should give you enough example that the story is far more complicated than that. What I'm trying to say here is scientists and astronomers at that time, since their instruments failed to detect the verification of a heliocentric view, that is the basis of their rejection, not because they were adhering to the church or they were adhering to some dogmatic assumption. They might have been, no doubt, but that is not the sole criteria. That was not the sole criteria. Got that? Next, we are going to talk about observational equivalence. So, for example, what does this mean? It means if two scientific theories are observationally equivalent, how do you distinguish one is more true than the other? Right? So, let's take an example of the black hole. Everybody hears about the black hole, right? Mm-hmm. Is black hole the only explanation for that phenomena? You'll be surprised. Let's look. I drew a table here. Can we see all the table? Yeah. So the black hole phenomena, the concept of black hole. Basically, black hole means something in a region where gravity holds back everything. Even light cannot escape it. Correct?
Yeah, yeah.
Right? So just look at it. Equivalently, we can say a black hole, we can call it a black star, we can call it a dark energy star, we can call it a gravis star, and a gravis star comes in two flavors. We have a fuzzball, we have a Kugelblitz, we have a black hole electron. All these are scientific theories explaining the phenomena that we are of an object so powerful, gravitationally so powerful that light cannot escape it.
Yes.
So how do we differentiate which one is more true on the other? I mean, according to what we have, the popular view, I think, I guess only
I've never
people.
heard the other ones before. Only,
I think you only heard of this one.
yeah, I don't recognize all these other ones.
That is, you understand? This is another aspect of science. How come we only know about this one, but not the rest of them?
Scientific reason.
Yeah,
Scientific politics.
that is
Scientific
correct.
politics.
That is correct. So that is where Kuhn's, Thomas Kuhn, who the philosopher of science, he came up with the viewpoint. I'm just trying to recap. This was on our first presentation. He says science and scientific theory is not solely based on empirical evidence alone. They are based on also sociological factors too.
Yes.
And the sociological factor in here is that the press only talks about black hole. Like tomorrow, if everybody, Discovery Channel and the History Channel and the Geographic Channel and everybody starts talking about a black star, people will forget what a black hole is.
Yes.
Yeah. Or they'll get confused between the two.
right?
Yeah.
Or if they start anything else, people will less, collective memory is very short. People will forget.
Yeah.
So it's just not empirical evidence alone that that satisfies this. You understand what I'm saying?
But I
So
think they should be teaching us all of that. I feel like the society becomes dumbed down when we don't learn everything.
that is one viewpoint of that's one
It'd be
viewpoint.
great that if everyone had at least some basic high level knowledge about all of these.
Mhm. I agree.
If all the Discovery channels and National Geographic or whatever, they all talk in the media. They talk a little bit about all of them. Then everyone would find this sort of thing more interesting.
But most people I talk to, you are right. But most people will say, "What the heck? I don't want to be interested in. Just give me the remaining results." You understand? And I use this as an example all the time. That is, what samai, what tarikh. How do people have started explaining this surah, the tarikh, the piercing star, right? They say, "Oh, it's a black hole. It's a black hole. It's a black hole."
Is it a black hole?
Why not a black star? I forget about being a black. Why not a black star on any one of this? Why black? You understand my question?
Yeah. Our interpretation, for example, in this example you're using, our collective interpretation of Surah
The Tariq.
Tariq is very limited because of our limited knowledge of what's presented to us on a day-to-day basis.
Correct.
In the universe.
So forget about whether it's justified or not from the Islamic point of view. It's not even justified from a scientific point of view. You understand?
People think that when they talk about science over religion, that they have a more broad-minded perspective of the world, but they really don't, because they don't have a broad-minded perspective of science.
Thank you. Thank you. So, brother Fawad, I just want to recap for you. Here we are talking about observational equivalence. When two theories,
Got it.
you understand? So now just think about it. That I was a part of it. I was listening to a khutbah when Surah Tariq was mentioned, and the person said, science today has proven that this piercing star is a black hole. Honestly, I just felt like I just melt away right there.
You almost fainted, right?
No, honestly, yes, I did. Because it was so, just think about it. From a scientific point of view, you don't know what the concept is. How can you then just use that concept to apply to Quran?
Yeah, it makes sense.
Okay. So I think I've done enough justice on the
Take questions.
Yeah, sure.
Are we done? I think we should be. So just on the last point here, physicists still are not sure. Just look at it. A physicist a very good physicist came up with the idea that mathematically black holes do not exist.
Mathematically?
Okay. So what is the other physicist responding to? He calls it, the paper is nonsense. Think about it. I will try to draw an example here so people can get a context. If a Maulana tells another Maulana, he's talking garbage, the third person who is scientifically minded says, you know what, religion is always fighting each other and then they're calling each other nonsensical. Religion is the junk. Correct?
Yeah.
What is happening here?
Same thing. Just what scientists.
That's a scientist.
One scientist is saying, scientist A is telling scientist B, what you're saying is, irrelevant, and B is like, no, what you're saying is relevant, and then scientist C is like, you're both, arguing with each other, the heck with science.
Exactly. So,
I'll move on to something else.
exactly. So, we always forget that. It's not a religious person who's calling it nonsense. They may disagree. There's disagreement is different. But look at the language he's using. The paper is nonsense. And that's why I put the quote there. So, I think we can...
Just start taking questions.
there are black holes and all these things. The next topic will take us very long to finish. Underdetermination, that's another problem with the scientific method. I think we have done enough justice to say that for observationally equivalent things. If you have any questions, comments, feedbacks, please go ahead. we will continue with from here under determination in the scientific method.